How does he do it every time?
To figure out how Steph Curry makes his three-pointers, we will find the arc length distance from his release point to the basket. The integral from 0 to time traveled of the square root of the horizontal velocity squared of the ball plus vertical velocity squared of the ball times dt gives us the distance traveled.
Since the three-point line is 23 feet and 9 inches away, or 7.24 meters, we know the initial horizontal position of the ball. Steph Curry releases the ball 6 feet and 3 inches above the ground, or 1.91 meters, so we know the initial vertical position of the ball. We know that it takes approximately 1.6 seconds for Steph Curry to score a three, with his average angle of shooting being 55 degrees and his average release velocity being 10.2 meters per second. The final position can be found by the equation x of t equals x initial plus velocity times cosine theta t, with theta being the shot angle and t being the time it takes for the ball to get to the basket. So the derivative of this would be velocity times cosine theta. The final y position can be found by the equation yt equals y initial plus velocity sine theta t plus 1/2 gt squared, with g being gravity. So the derivative of this would be velocity times sine theta plus gt. Using the values we've already established, we can plug them into our derivative equations. So dx dt would equal velocity, which is 10.2 meters per second, times cosine 55. This equals 5.85. dy dt would equal velocity, which again is 10.2 meters per second, times sine 55, plus the acceleration of gravity, which is negative 9.8 meters per second, squared, times the time it takes the ball to get to the basket, which is 1.6 seconds. This equals negative 7.32. We can plug these values into our original arc length formula to find the arc length that Steph Curry uses to splash all of his threes. Can you guess what the arc length is? If you guessed or calculated correctly, you know that Steph Curry's arc length is 14.99 meters.
Calculus!